Okay, guys, this is for section 1.1, the first half, it's really not half, but the first part, how about that, of pre-calc. And the first thing we need to do is start with the definition of a function. A function is defined as a set of values where for every x value, there's only one y value. I realize at first that the definition is definitely going to be confusing. I need to say it doesn't mean for every y value there's only one x value. It doesn't go both ways. The definition is for every x there's only one y. So I'll show you some examples of things that are functions and things that aren't. So here's a graph of an object. For -2 for an x value, notice that you have this y value as well as this y value. So for that value of x, there are two different y values. So this would not be a function. For every x, there's supposed to be one y. Here's an x that has two different y's. So this is not a function. Here's another one. For this value of x, there are two different y values. Two different y's for all of these. This is not a function, because for every x, there's supposed to be only one y, and there isn't. And what I'm trying to show you guys is from the picture and from the table, and I'll come back to the picture in just a minute from the graph. Now here's one. For every x, there's only one y value. This is a function. And what you guys might remember back from Algebra 2, a way to visually tell if something was a function or not is if you could draw a vertical line. Now that's assuming I can draw a vertical line. Draw a vertical line through it. If it only intersects the graph once, then it is a function. This is because it passed the vertical line test. Coming back to these other ones that failed, it failed the vertical line test because for this particular value of x, 1, 2, 3, 4, for a value of 4, there are two different y values. So this is not a function. Same thing here. For any given value, for any given value of x, there's more than one y value to go with it. It's failing the vertical line test. For that vertical line, it's showing you an intersection in two different locations for that x value of -2. So for x -2, there's more than one y, and there they are right there. Okay? Sorry to have that show up on front there, you guys. Let's see. So let's go back to this. All right. So then you're going to be given the equations and asked, are they functions? Well, the easiest way to do it is to graph it. So you stick that thing in your calculator, and you're going to find that you get this parabola that's looking like this. And you go, yeah, sure enough, it passes the vertical line test, so it is a function. So the answer for that one is yes. This one, I'm really hoping you guys recognize that thing. Minus 5x plus 2 divided by 3 minus 5/3 x plus 2/3. That's just a line, you guys. It happens to have a negative slope, so you get a line that's going like this. It's going down. Is it going to pass the vertical lines test? Heavens yes. Okay. This one, subtract the 5x. Take the square root of both sides. And when you guys put a plus, or sorry, I just gave it away. When you guys put an even root on the page that wasn't there before, remember a plus or minus is going to show up. And then you put that thing in your calculator and you graph it and you look at it. I believe, and I could be wrong, that this is going to be some kind of parabola facing left, I believe. Okay? Could be wrong on that, but I think that's what it is. Either way, graph it, look at it, whether I'm correct or not, imagining what this thing looks like, it would fail the vertical line test. But you can verify that by sticking it in your calculator and graphing it. Now, that brings up an interesting question for some of you guys that like to overgeneralize rules. Solve for this one. So you get y squared minus 4x squared plus 9, or if you really want to write it this way, that's okay too. 9 minus 4x squared. Either way, you're going to square root both sides. Don't forget the plus and minus. 9 minus 4x squared. Okay. If I gave you guys 9 times 4 times x squared, so this is all a product, and it's all inside a square root. Yes, by all means, you can write 3, 2, and x. But you can't do that when you're adding or subtracting. This does not simplify. This is as good as it gets. One way to show you why, 9 minus 4x squared, that's raised to the half power. A square root is the same as an exponent of half. You guys have learned that you can't distribute an exponent over adding and subtracting. I mean, a simple example of that, 3 plus 5 is 3 plus 5. 3 plus 2 is 5. 5 squared is 25. If you distribute this thing in, you get 3 squared plus 2 squared. 9 plus 4, it isn't 25. If you can't do it when your exponent's a whole number, you certainly can't do it when, you just can't. It doesn't work, you guys. In fact, as I was writing this one, I realized I forgot to mention something back up on this one. When you go to graph this in your calculator, you have to enter 2 equations. On one line, you enter the positive minus the square root of, I can't pronounce it, but I'm writing it correctly, the square root of negative 5x plus 2 and negative square root of minus 5x plus 2. That's how you type in the plus and the minus. That's how you get it to show up, is you have to type in 2 different equations. This is the positive version, but you obviously don't have to put anything there. And remember, this is going to be a negative, not a subtraction symbol. You'll get an error if you hit subtraction here. Just like you have to use the negative symbol there and a negative symbol here. Okay, and by the way, you can't distribute this inside the parenthesis. It doesn't work. You can't, or inside the radical, you can't distribute that in. So, remember, you guys, don't overextend, over-apply the rules that you guys know for when you're multiplying or dividing to when you're adding or subtracting. You can't. That doesn't simplify. Okay. Then you're going to get a different, so changing gears, changing topics, you're going to get a section that says find all real values of x such that f of x equals 0. Find all real values of x where x, such that f of x equals 0. It would help if I could just read it. All right. They're telling you literally f of x is 0. Just let this be 0. Well, one way you could solve that is think of it as a proportion. So you'd have 0, because 5 times 0 is 0, equals 12 minus x squared. How about add the x squared over? I'm extracting the root. Letting you guys hear that word, those words again back from last chapter. Square root both sides. X is equal to plus or minus 2 square roots of 3. So that would be your answer. You just set whatever f of x is equal to 0 and solve it using all the different methods that you guys practiced last chapter. Then you get a style of question that says, find all real values of x such that f of x equals g of x. Well, there's a g of x. Oops, let me get this off of there. There's an f of x. So when is f of x equal to g of x? Well, when is 12 minus x squared over 5 equal to 2x plus 3? If I put this over 1, you can see it's a proportion, cross multiply. 10x plus 15 is equal to 12 minus x squared. And you guys totally have the skill to solve it from there. Okay? Whatever the functions are, set them equal to each other and solve using the skills that we've been practicing last chapter. Evaluating functions. You guys, I think, are good enough that you, no problem, can go, okay, whatever I fill in here, I fill in there. It's just a recipe. So if I'm putting a 5 there, I just put a 5 here. When it starts getting to be letters and numbers together, sometimes you guys get a little wigged out by it. So I'm going to show you a process that will always work. Write your function first without the parenthesis, and then fill into it whatever is in there here. Now you may think that's awfully tedious for something as simple as that one, but trust me, for some of the harder ones, you guys are going to be like, not so bad. It actually worked. So write the function first, then worry about what you're filling in. So 3c minus 2 would be your answer. Here's another great example of it. I'm going to write 3 times whatever is in the parenthesis minus 2, because that's what the recipe calls for. Whatever is here is here. 3 times that stuff, and that stuff is x plus 2. Distribute the 3 inside. So your answer is 3x plus 4. Okay? Continuing with that idea, put parentheses in place of the variable, and then fill into it whatever is inside that parenthesis. 5, 5. So your answer would be 5 square root of 1, which is 5. If the value is c, parenthesis minus 4, and then fill into it a c, so it's c square roots of c minus 4. If it's x plus 2, doesn't matter. Put parentheses in place of the variable, and then fill in whatever is inside that parenthesis. Now this outer paren I can't take off because the square root distributes to both of them, so unfortunately that's got to stay there. X plus 2 square root x minus 2. Now that one can come off because it's all inside it. So that's as good as this answer is going to get. It doesn't simplify any further than that. Okay? Something tells me that's the end of this first section. For section 1.1.